Okay now, let's put those terms to use with some simple math. Ohm's law and Watt's law. There are many other formulas out there, but these are the two you should use frequently or at least understand. It will make troubleshooting easier. I mentioned earlier there are two types of loads, resistive and inductive. When working with Ohm's and Watt's law, we are talking purely resistive loads through this exercise. Inductive loads have other complicated formulas, and we will not cover those in this program. I will explain why when we get to troubleshooting inductive components. Ohm's law. E for electromotive force is voltage measured in volts, the potential difference from one point to another. R for resistance to the flow of current measured in ohms, and I is intensity or current flow measured in amperage or amps. You can use Ohm's law to determine one factor if the other two factors are known. If my voltage is 120 volts AC or DC and my resistance is 24 ohms, I divide 120 by 24 and I have 5 amps flowing through the circuit. If I have 5 amps and my resistance is 12 ohms, I multiply the two to get my voltage of 60 volts. When doing these simple formulas using AC or DC does not matter. The formula is consistent with either. Watt's law. Wattage expressed in P for power is the amount of power used or created. You get wattage by multiplying your amperage and your voltage. By having any two of the numbers, you can get the third number. Many resistive components like heating elements that we use will be rated for wattage and voltage. So, at the given voltage, this will produce or use a certain amount of power. And if we know the heating element is rated for 600 watts with 120 volts applied, then I know my current will be 5 amps. If I have 208 volts applied and my current is 6 amps, I will be using 1,248 watts of energy. This is pretty consistent on resistive loads. Inductive loads requires more calculation that I said we won't cover. However, the purpose for understanding Watt's law and Ohm's law is when you use them in combination, they help you troubleshoot and also determine installation needs. I work with a lot of food service equipment, so they will be my example. Understanding these formulas help you solve problems faster. We will explore this more in depth when we get into the heating element section.